Hello and welcome to the presentation of our poster Debugging Inputs by Lukas Kirschner, Ezekiel Soremekun and Andreas Zeller. I am Lukas Kirschner and I am glad to be here with you at the virtual ICSI 2020. Program failures are often caused by invalid inputs. So, for example, a user might want to feed a JSON input into a program in order to get data out of it. If the input is invalid and the program cannot handle such invalid inputs, the result might as well be a crash. To get the passing input, one needs to debug the data. The delta debugging algorithm was originally designed to minimize test cases. Our maximizing delta debugging algorithm tries to maximize the passing data from an input file. More precisely, we try to minimize the part of the input that is deleted before it is processed by a subject program. We propose a lexical variant of the ddmax algorithm that works on the character level and a syntactic variant that works on the parse tree of a parsed input file. Let us consider this JSON example, which fails because of two inserted asterisks before the 3. If we minimized this invalid file with the regular delta debugging algorithm, we would get a single curly brace as output. Our maximizing delta debugging algorithm would remove the two asterisks and give us a passing output. Therefore, we can consider those two asterisks as our ddmax diagnosis, which is the difference between the repaired output and the original input file. Let us now dive deeper into our algorithm and see how the lexical ddmax algorithm actually works. We again take our snippet from before and try to repair it with the lexical ddmax algorithm. In each round of our algorithm run, we take a subset of the input and delete it before testing. As you can see on the right-hand side, none of our attempts succeed. In the second step, we try to delete everything that was not deleted in the first step. Once again, we cannot find a passing subset. If both the first and the second step fail, we double the granularity, which means that we halve the size of the subset that we choose to be deleted in each round. If we find a passing subset in the first or second step, we exclude everything that passes the test and continue with the rest. We start over with step 1. We eventually find a passing subset with minimal deletion, in this case after 39 steps of our algorithm. Let's now have a look at our research questions, in which we want to evaluate how prevalent invalid inputs are in practice, how effective our repair approaches are, and how much data we managed to recover. As you can see here, we crawled about 7,000 files, of which 295 were invalid. We have the 3 file formats JSON, wavefront object, and dot. Some files were rejected by their grammar, some by one subject, and some by all of our subjects. For our syntactic approach, we used the Entler parser generator, and we compare the lexical and syntactic ddmax to the error recovery strategy of Entler itself and the baseline, which just means that we feed the unmodified input file into our subject program. Our 3 sets of test files consist of real-world invalid files and artificially mutated files with single and multiple mutations. Those mutations consist of random insertions, deletions, and bit flips, which is as close to the real world as possible. We noticed that syntactic ddmax performed slightly better than lexical ddmax. In total, ddmax repaired about 69% of all files. Concerning the data recovery, we noticed that lexical ddmax recovered most, about 70%, of the input data. There are some limitations in our approach, most importantly that we are limited to subsets, so we can only delete stuff from our invalid files when we repair them. We repair the data, not the information, so we cannot make any guarantee about the semantics of a repaired file. And when we have multiple errors in an invalid file, we can only repair all of them. We cannot repair multiple errors independently. To sum it up, we proposed the lexical and syntactic ddmax algorithm, which in our evaluation managed to repair most of our invalid input files. I thank you very much for your attention, and if you are interested, you can download the full paper at the link shown below.